Nuclear fusion is two words. Nuclear, the process which involves a nucleus, and fusion, the combining of two or more entities merging to form one entity. Therefore, nuclear fusion is a combination of two nuclei, a nuclear reaction in which the lighter nuclei are merged to form a product with a heavier nuclei, with the release of an enormous energy. But in order for them to merge, you would need to overcome the Coulomb force preventing the nucleus from fusing. For example, on the Sun, which is ridiculously huge, knowing that the mass is directly proportional to the gravitational force, meaning that the Sun has a huge gravitational force over 30 times more than the Earth. This helps initiate the nuclear fusion reaction by pushing atoms closer, compressing them into a smaller volume, which will result in more energetic movement, increasing the heat. Not to mention the high temperature already needed, which causes the atoms to move around more energetically as well. But that is still not enough. Therefore, the final thing needed is quantum tunneling, whereby the atoms will sort of tunnel through the barrier made by the Coulomb force. These are for the atoms that don't come close enough to fuse.
Nuclear fusion, as mentioned before, is a combination of nuclei, a reaction in which lighter nuclei merge to create a product of heavier mass and a release of energy. Let's look at an atom. An atom is made up of neutrons, protons, and electrons, although we will only be looking at the nucleus, which is made up of protons and neutrons. It takes energy to hold these neutrons and protons together, which comes from a force called nuclear force, which is a very strong attractive force. Hydrogen has one proton, and deuterium has one proton and one neutron. Let's say hydrogen has an energy level of 1 and deuterium an energy level of 4. When merged, they produce the product of helium with an energy level of 4. According to the law of conservation of energy, energy cannot be created or destroyed. So you're probably wondering what happened to the other energy level, accountable for the missing energy. The extra energy was shot off as light, known as a photon. A photon is a wave of electromagnetic energy which can be absorbed by energy plants and then converted into other types of energy, like kinetic and thermal.
In the example, this helium atom is lighter than the mass of the other two atoms combined. Therefore, the mass is lost in the form of a photon, and in other cases the mass can be lost in the form of a neutron, where the lost mass can be measured with Einstein's equation E equals mc squared. Therefore, satisfying the law of conservation of energy, since if you consider mass as a form of energy, which you should according to Einstein's equation, the law isn't broken.
Created using Powtoon.